In this problem, we're considering the home sales, which we're going to measure as the thousands of homes sold, as a function of the number of Arizona full-time employees, which is measured in thousands also. So the first thing that we're going to write down is what our variables represent. So M is thousands of employees in Arizona, and H of M, so the house sales as a function of the number of employees, is thousands of homes sold. The very first thing we want to find out is what is, in part A, H of 68. Okay, well, that's asking for 68,000 employees in Arizona, how many homes would we expect to be sold? So having this all enter this into my graphing calculator, gone out to table, I can see that typing in 68 gives me about 231.72 thousand homes sold. And that is when we have 68,000 employees. That's the prediction based on this equation. Now we want to find the derivative of this function. So h prime of m. So I'm going to write this thing out. 5.1424 m to the third minus 1058.6 m squared plus 72541 m minus 1654525. And so I'm going to kind of progressively show, okay, the 3 is going to come down and multiply, we're going to subtract 1. The 2 is going to come down and pre-multiply, we're going to subtract 1. This is a power of 1, so when we bring that down, we're going to subtract 1. And so our constant will go away since the derivative of a constant is 0. So 3 times 5.1424, 3 times 3 times 5.1424 gives me 15.4272. And I'm just going to be careful with my rounding here, only because I've worked through this and I know that what ends up happening is the rounding error creates some big differences, because some of these terms are extremely small and some of them are extremely large. So you kind of want to be careful of that. We have a 5, then we have a negative 7,000, then we have a 72,000, and a negative 1,654,000. So their numbers are all over the place. So I just want to make sure I kind of round carefully. So I'm going to be consistent with what we have. And 2 times 1058.6, or 1058.6, excuse me. Doubling that gives 2117.2, so minus 2117.2, and this is m to the first power. And then this, of course, m to the 0 goes away. That's just 1, and so we're going to be left with 72,541. Now we want to explain what the inputs and output variables of this function represent. All right, well, m doesn't change. That's still 1,000 employees. But now we have a rate of change function, so h prime of m, the output, is going to give me 1,000 homes sold per 1,000 employees. Now what you can do is you can actually just reduce this to homes per employee, because both of them are in thousands, so the thousands technically mathematically can be canceled out. But either way, either unit works. 1,000 homes per 1,000 employees, or just homes per employee. I kind of like this one better because it shows me what's happening at the single employee level. Now we want to find and explain the real world of h prime of 68. So I'm going to enter my derivative into my calculator, and I'm going to have to do it twice, see here and here. So I'm going to go ahead and just enter this into my y equals screen. I cleared this out because I don't need it anymore. So I'll do 15.4272 x squared minus 2117.2 x plus 72541. And now I'm going to go to my table. So just going to double check real quick. Everything looks to be entered okay. Second graph. And now I want to know h prime of 68. And it looks like h prime of 68 is a negative number. So h prime of 68 is negative 93.23. Now remember, this is homes sold per employee. Well, so what does this say? If there are 68,000 employees in Arizona, now I believe this is federal government. These are government employees. Then the then there is a decrease of 93.23 homes per employee. So in other words, as for each additional employee at 68,000, we would expect that that 93 fewer homes are sold for the next employee that's hired. Now this seems bizarre, but let's go ahead and take a look at part D, which will have us, part E, which will have us analyze this in a little bit more detail. And they're asking for a real-world cause. So the real-world cause that we might think about here is that, well, even though there's 68,000 employees, you might think that the more employees, that more homes would be sold. But one possible explanation would be that maybe this relationship between this number of employees and the total number of homes sold was based on an economic downturn. So maybe that particular employee count with that particular home sold count just corresponded to a time when there was an economic downturn, and even though maybe the government hired a few more employees, the number of homes sold was headed in the opposite direction because people were getting laid off in other places. So that might be a possible cause. Now we want to find and interpret h prime of 73 and then interpret what that means. So we'll do h prime of 73, and so I'll just come in here and I'll change the 68 to 73, and this gives me 196.95. Okay, well this means a similar interpretation. When there are 73,000 employees in Arizona in the government, then there is an increase of 196.95 homes per employee. That's what's anticipated to happen. So we expect that as more employees are hired now, the number of total home sales in Arizona goes up more drastically. Now keep in mind, it's not that one more employee is hired and that person buys 197 homes. If government's hiring more at this point, then it seems like the total number of homes sold overall. Maybe other industries are hiring as well outside of government, private sector, and the public sector. So that might be a possible explanation, that maybe now economic boost is taking place when we experience this many employees. So maybe when we started experiencing this many employees, we were starting to have an economic boost, and so more homes were being sold. And so the rate of growth of home sales was increasing for each additional employee hired.